All right. Today we are diving into a hidden dimension of mathematics. Seriously, it's a story about a problem that stumped the greatest minds for centuries and how a simple, almost ridiculously brilliant idea changed math forever. So, let's jump right into the incredible world of complex numbers.
Everything, and I mean everything, kicks off with this one little question. It almost looks like a mistake, right? We learned from day one in math class, a negative times a negative is a positive. A positive times a positive is, well, also a positive. So how on earth could you multiply any number by itself and get a negative one?
And for a very, very long time, that was the official answer. You just can't. It's impossible. End of story. In the world of numbers we use every day, the ones you see on a ruler or a bank statement, this question was a complete dead end, a solid brick wall.
That wall has a name. It's the real number line. It's that familiar line stretching from negative infinity all the way to positive infinity. It holds all the numbers we're comfortable with. Whole numbers, fractions, decimals, you name it. But there's just no room on it for the square root of a negative number.
Now this is where the story gets really good. Instead of just giving up, some incredibly clever mathematicians decided to do something, well, kind of crazy. They figured if the number they needed didn't exist, they just invent it. They decided to literally imagine a new number into existence.
And that single act of mathematical creativity gave us the key, a key that would unlock an entire new universe of numbers. They called it the imaginary unit.
So meet I. The concept is just beautiful in its simplicity. We just define I to be the number that when you square it, you get -1. That's it. It's a new rule for the game. We're just declaring that the square root of -1 is no longer impossible. From now on, it's I.
And you might think inventing a number would just lead to chaos, but I is surprisingly well behaved. Its powers follow this simple, repeating cycle. First you have I, then if you square it, you get -1. Then -I, then +1, and then the whole pattern just starts over again. It's this beautiful, predictable rhythm that makes I so incredibly useful.
So now that we have this stable, predictable new number, we can finally break free from that one-dimensional line. We can start to explore a brand new dimension. And that brings us to what we call a complex number. The standard form looks like A plus BI. Now, the key thing here is that every complex number is like a 2-for-1 deal. It has a real part, the A, from our old familiar number line, and an imaginary part, the BI, that's built with our new friend I. And here it is. This is the big aha moment. On the left, you see our old world, that flat, one-dimensional line. But by creating I, we can now draw a second axis, a vertical one, for all the imaginary numbers. And just like that, we've gone from a line to a plane. We've added a whole new dimension to our numbers.
This new two-dimensional map is called the Argand diagram, or more commonly, the complex plane. And just like any other map, we can use it to pinpoint the exact location of every single number. Let me show you what I mean.
Check this out. Finding a number like 2 plus 3i is super easy. You just go 2 units over on the horizontal real axis, and then 3 units up on the vertical imaginary axis. Boom, there it is. What about something like 3 minus 5i? Same deal. You go 3 units to the right on the real axis and 5 units down on the imaginary axis. Every single complex number has its own unique address on this plane.
Let that sink in for a second. We have totally broken out of the prison of the number line. Numbers aren't just stuck moving left and right anymore. Now they have the freedom of a whole two-dimensional plane. They can exist anywhere on a flat surface. It's a huge conceptual jump.
Okay, so at this point, you might be thinking, that's a neat trick, but so what? Why does any of this matter? Well, it turns out this so-called imaginary world has some very, very real power.
You see, complex numbers basically complete mathematics. They let us factor things we were told were impossible to factor, like the sum of 2 squares. They guarantee that every polynomial equation actually has a solution. They create this profound link between algebra and geometry, and they help us solve problems that were completely out of reach when we were just stuck on that single number line.
And I just love this bit of history. The famous philosopher and mathematician René Descartes was the one who came up with the name imaginary, and he kind of meant it as an insult. He thought they weren't real. But then, about 100 years later, the legendary mathematician Leonhard Euler came along and standardized the symbol I. basically giving it the official stamp of approval and making it a core part of math.
So, it all leaves us with this really cool thought. A problem that seemed totally impossible was cracked just by inventing one new rule. It really makes you wonder, doesn't it? What other mathematical walls are we staring at today that are just waiting for one more creative, maybe even imaginary idea to come along and tear them right down?